Good morning everyone. I am Rajdeep Singh. Today we are going to learn about vector access memory scheme. In earlier lecture or in earlier video I have taught you about deadlock, vector instruction types. Now today we are going forward with vector access memory scheme. So as I taught you earlier that in vector processing, vector data is being loaded from main memory into vector registers. So these flow of vector operands between main memory and vector registers are usually done in pipeline fashion or pipeline manner or through multiple access paths. Vector operands are not necessarily stored in contiguous memory locations. To access a vector in memory, one need to specify base address, its stride and length. So here we are going to learn about two things. First is vector operands. What is vector operand specification, and second one is vector access memory scheme. There are three type of vector access memory schemes: CXs, SSs and C/SSs. So moving on to vector operands. Vector operands are actually collection of scalar data. What is vector data? Vector data is nothing but collection of scalar data in a fixed format or of same type. Vector operands may have arbitrary length, and they can be stored at different locations of the memory. So it is not needed that they are stored at contiguous location. So to access such type of data, we need some simultaneous or concurrent access through some method or through some organization, so that we can access more than one word of memory at a time. So to access vector data in memory, one need to specify what is the base address of that vector data, what is its stride and what is its length. Each vector register has a fixed number of component register. Therefore only a segment of vector can be loaded. Now if suppose vector data is longer than that or too long, then it is segment by segment, it is being loaded segment by segment and part by part. Now vector operands that is to be accessed should be stored in memory and should be allowed for parallel or pipeline access. How it is accessed? This was about vector data or vector operand. Now how these vector operands are being accessed and loaded into the vector registers. So there are three approaches by which we can access the vector operands. First one is C access memory organization, second one is S access memory organization, and third one is C/X access memory organization. Actually C stands for concurrent access, S for simultaneous access, and C/S is combination of both the former approaches, that is concurrent and simultaneous access. One by one we will have a look about what are these memory organizations are about. So first one is a C access memory organization, and as you can see in this slide, it is clearly written that it is M-way low order interleaved memory structure. So as you have learnt in unit 2 about memory interleaving or interleaved memory organization, there were two type of interleaved memory organization. One was low order interleaving and one was high order interleaving. So C access is exactly same as low order interleaved memory organization. If you remember, you can I taught you about low order interleaving, that batch access was possible in low order interleaving, whereas in high order interleaving it was not possible. So here the application of that low order interleaved memory organization is here. So whenever you have to define C access memory organization, you have to exactly define what you have defined in low order interleaved memory organization. Here C stands for concurrent, obviously, and as in low order interleaved memory organization, low order A bits were used to select the modules, and high order B bits of the address were used to select the word which is to be read within each module. Now in this block diagram, CX's memory organization, you can easily correlate it with low order interleaving because it is exactly same diagram where let me explain you. This is the memory address which has been divided into two parts. First part is low order A bits, which is used to identify the modules which are to be read. So it has this A bits of module has been sent to address decoder, and it then identify through this module address buffer that which module is to be read. And second part, this high order B bits, is by the help of word address buffer, it is used to identify which word of this module, these modules are to be read. Now one thing which is to be remember in this low order interleaved memory organization, or CX's memory organization, actually, that organization of memory module, what is these? What are these? M0, M1, M-1, these are M logical partition of memory. And how it is organized? So if 0th word of the memory is stored in first block, then next, that is first word, will be stored in next M1 block, and second will be in M2 block, and so on. So in this way modules are arranged here horizontally. Addresses are arranged in a horizontal manner. So this was about C-axis or concurrent axis memory organization. Moving on to S-axis memory organization. S stands for simultaneous, as I told you, and here low order interleaved memory organization is slightly rearranged, so it allows simultaneous access. What is difference between simultaneous and concurrent? Actually, in concurrent access, few number of modules are read and few are not read. It depends on requirement what modules are to be read. But here in S-axis memory organization, all the memory module will be accessed simultaneously in synchronized manner. All the words will be read at a time, and all the memory modules will be accessed. No memory modules will be left. Here same, those B bits will be used to select the word of the module, and at last those M words are latched by using data buffer, and low order A bits are used to multiplex those M words to the output. Slight difference in the diagram. Here you can see that this n minus a, n is the n is actually the address, total length of the address. Just a second. Yes, this n minus a means B bits is used to identify which word of the modules are to be read. Now after these addresses are latched into a latched by using the data latched, and this A order low order address bits are used for multiplexing it into a single output of the word which has to be accessed. So this is X-axis memory organization. Here one thing which is to be remembered, that all the modules in the organization has to be read simultaneously. No modules will be left. Okay. So moving on to third organization, that is C/S memory organization. And this is actually the combination of both the former approaches, that is concurrent one and simultaneous one. Here n access buses are used with m interleaved memory modules. So m modules on each bus allows C access, that is concurrent access. Then n buses operates in parallel to allow S access. So simultaneous access and concurrent access both are being done here. So in total, if we say m modules are being read by concurrent access, and n buses are being operated or read by using simultaneous access. So total words which are being read is m into n. So here you can say see that these are the m memory modules on which are low order interleaved and provide the concurrent access, and here m modules which are providing simultaneous access. So both this organization is combination of both the approaches, and here we can read m into n words simultaneously. So this was all about vector access memory schemes. In vector access memory scheme, what we have read that vector operands, how vector operands are being loaded into main memory, from main memory to vector registers. They are this is usually done by using pipelined or multiple access paths. We learned about vector operands, what are the vector operands, and we learned about three main memory access scheme, vector memory access scheme, that is C access, S access, and C oblique S access memory scheme. Concurrent access, simultaneous access, and combination of both. So in next lecture we are going to learn about SIMD computer organization. So till now, if you have any doubt, you can post me on comment of this video, or you can directly message me on WhatsApp. I'll try to resolve it as soon as possible. As an experimental basis, to enhance the quality of these video lectures, I am posting this lecture by preparing its video beforehand, because till now we are actually giving you lectures on FB Live, which was not that much clear and was blur. So on the experimental basis, I am making this video beforehand and will post it at the same time when I was giving FB Live, and for that half an hour I'll be online to entertain your queries, and will try to resolve it there and then. Thank you so much.